The next skill that will be important for you to be able to do, the next algebra skill that will be important for you to be able to do in order to be successful in geometry, is to simplify radicals. And so the purpose of this lesson is for you to be able to use factorization to simplify radicals. And this lesson may seem a tad erroneous for now, erroneous meaning that you might not exactly see how it applies to geometry, but when we get into the study of triangles later on, being able to factor radicals will be an extremely important skill. So let's just review a couple of things really quickly. First of all, what is a radical? Well, a radical is just this symbol. That is the actual definition of what a radical is. It's just this symbol. You may be saying, hey, well, I don't know it as a radical symbol. I know it as a square root symbol, and that's the same thing, that this is a radical. So when we talk about simplifying radicals, what we're actually talking about is being able to take a number that is underneath a radical and factor it so that we can make this radical simpler, so that we can make math a little bit easier to do. And we're going to start with an example of just factoring first before we get to the radicals. So I want to take the number 96, and I want us to factor this. And you probably have done this in the past with factor trees. And so let's make a factor tree, and then when we get all the prime factors of 96, we'll see what's left. So it might be helpful to take out a calculator to see what all the different factors of 96 are. So obviously 96 is an even number, so let's see what we get when we divide 96 by 2, 48. So we could use 48 and 2 if we wanted to. But let's see what else there is. Let's see what's the next even number? I don't know, 4. So let's divide 96 by 4. 24 and 4. So instead of using 48 and 2 here, two more factors of 96 are 24 and 4. But I'm going to keep going just to prove a point. Let's see if 96 is divisible by 6. It is. 16 times 6 is 96. And those are the two that I'm going to use, and we'll get into exactly why I chose to use those in a second. Okay, 16 and 6. Now neither of those are prime numbers, so we need to continue working. So now let's look at the factors of 16. 16 is actually a square number, so it has two perfect factors, 4 and 4. 4 times 4 is 16. And 6, there's only two factors of 6. Those are 3 and 2. Okay, so we're done on this side. 3 and 2 ends our tree going this way. Let's look at 4 and 4. Now obviously 4 and 4 are also perfect squares, and the two factors that go into 4 and 4 are 2 and 2. So two 2's go into each of them. Now what does this actually mean now that we're done with this factor tree? Well, what it means is that I could rewrite 96 as a combination of all of these factors down here, as a multiplication of all of these factors. In other words, that these are the simplest factors of 96, that I'm going to write all the 2's together and all the 3's together. So we have 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, and 5 times 1, 3, that is the same as 96. So that is called a prime factorization of 96, getting all of these numbers in their simplest form. And of course, as we learned in the last couple of lessons, that I can rewrite this, that anytime I do repeated multiplication, that's why we have exponents. So 2 multiplied 5 times is the same as writing 2 to the 5th times 3, and that equals 96. And so we're going to come back to this, but I want you to remember this process, because this skill is going to be extremely important in you being able to simplify radicals, especially looking for squares inside of other numbers. That's 16 as a square, and 16 times 6 equals 96. So let's jump into a couple of examples, and then maybe you'll see exactly what I mean. Here's the square root of 25. Okay, I'm going to rewrite the square root with its prime factorization. Okay, so 25 is clearly a square number. That 25 is also the same as 5 times 5, or 5 squared. And actually, something that you will learn one day in Algebra 2 is that writing a square root is the same as writing a fractional exponent. Here's what I mean, that if I want to take the square root of x, another way for me to write this is to write x raised to the 1/2 power. That these two are mathematically equivalent. So if you look at this, this is the same, 5 squared, square root of 5 squared is the same as me writing 5 squared to the 1/2 power. And what is 2 times 1/2? Well, 2 times 1/2 is 2 over 2, and 2 over 2 is 1. So this just equals 5 to the first power, which of course is just 5. And you don't need to know this thing about square roots being fractional exponents, but what I wanted to show you with this example is that using square roots and using radicals is actually just an extension of our exponent rules, that we just actually used the power rule right here to solve this problem, that radicals are nothing different than you already know, that they're actually extensions of the exponent rules that we already learned. And so of course you probably had the square root of 25 memorized, that was 5. You didn't need to do all of this work, but I wanted to show you this to show you the full process and kind of explain to you why we use radicals and where that math comes from. So let's go down to this example, and maybe you will see some more of what I'm talking about. So let's rewrite 24. And I'm going to rewrite 24 as 6 times 4. Why 6 times 4? Well, I know the factors of 6 are 3 and 2, and I know the factors of 4 are 2 and 2. 4 is a perfect square, and so I could rewrite this like this. The square root of 6 times 4 is the same as the square root of 6 times the square root of 4. And here it's a little bit easier to see that the square root of 4 is 2, and the square root of 6 is just 6, is just square root of 6. So the square root of 4 is, so this is the same as square root of 6 times 2, which we actually technically write as 2 root, or radical 6. And that is the answer. Square root of 24 simplified is 2 radical 6. Okay, let's continue with a couple more examples. Okay, here is our number earlier, 96. Now it's underneath a radical, and we need to simplify this radical. So how are we going to do that? Well, like I said earlier, I know that the square root of 96 is the same as the square root of, what are some factors of 96? 16 and 6. Now, why did I choose these? Why did I choose 16 and 6? Well, I chose 16 and 6 because I knew that 16 is a square. It's a perfect square. And so just like in our last example down here, 4 is a perfect square, and I know the square root of 4 is 2. So that actually makes my life a little bit easier. It makes this problem easier when I'm able to draw out factors that are perfect squares. So when you're doing this, you always want to look for a factor of these numbers that's actually the biggest perfect square. And 16 is the biggest perfect square that goes into 96. And so let's talk for a second about what those perfect squares are. Well, we know that 1 is a square. 1 times 1 is 1. So let's move to the next number, 2. Well, what's 2 times 2? 2 times 2 is 4. 3, what is 3 squared? 3 times 3 is 9. 4 squared is 16. 5, 25. 6 is 36. 7 is 49, and I'm going to stop there, but we could keep going. And here's why I'm doing this, is because I want you to see that these are all squares. These are all perfect squares. So when I'm using the factors of these numbers to simplify this radical, I want to be looking for each of these numbers because it'll make simplifying these radicals easier, and that maybe this process will actually help you kind of memorize these square numbers, these numbers that are perfect squares. And why are they helpful to know? Because when I do this, I'm going to separate square root of 16 times 6 into square root of 16 times square root of 6, and then it is easy to see that that becomes square root of 16 is 4, and just like in the last problem, the square root of 6 cannot simplify any further, so it is just the square root of 6, and square root of 96 is simplified to 4 root 6. So what happens when we have a number already out in front of the radical, like here? There's this 3 that's sitting out here. Well, remember, 3 root 60, there's a multiplication hidden within here, that this really is written as 3 times square root of 60. It's the same as if, we write a times b. I could write a times b as just ab. Those two things mean the same thing. 3 root 60 is the same as writing 3 times root 60. So really there's just a hidden multiplication in there, so keep that in mind. Okay, so let's think about 60. What are the different factors of 60? Well, let's see. 60 divided by 2 is 30. Neither 30 or 2 is a perfect square. 60 divided by 4 is 15. 15 and 4, okay, well there we go. 4 and 15 are 4 is a perfect square, so let's work with those factors. So I'm going to rewrite this as, remember this 3 is out here, times square root of, I'm going to rewrite 60 as 4 times 15. And now I can rewrite this as 3 times root 4 times 15, root 15. Okay, and then we just need to simplify. That 3 root 4 is, of course, 2, and root 15, now let's see, can we simplify 15? Well, 15 is 3 times 5, and we don't have a perfect square in 3 or 5, so that actually just stays the same. That stays root 15, and this becomes 6 root 15. So I hope this video gave you an idea of how to simplify radicals looking for these squares, and I hope it gave you an idea of why we do this. These numbers are actually simpler to work with when we do math, which we'll see more in the next lesson. And that really, just as we saw up here in this example, that this is just extensions of our exponent rules, that we're really doing our exponent rules more. And you'll learn more about that in Algebra 2, but you just need to be able to do this basic prime factorization, not very in-depth, not too complicated, but this basic prime factorization in order to do some triangle math later in the semester.